Hello and welcome to this video about BlHeli and how you can quickly and easily flash BlHeli onto most ESCs that are available today. Now, in this video's example, we will be using Naze32 Rev 5 as a bridge between the ESC and the computer. We will be using Afro 12 amp ESCs as the ESCs that we're going to flash BlHeli onto. They come pre-flashed with Simon K, with the Simon K bootloader. Now it's important to note that only ESCs that come with the bootloader will be able to be flashed with this method, because if you don't have a bootloader, you will have to use a separate programming chip that you'll have to create either using an Arduino or a different programming board. That's an entirely separate topic. I will link in the video description where you can find more information on that. But just for this video, we will just be flashing BlHeli through a Naze32 using the pass-through feature that's available on this particular flight controller and pretty much every flight controller you can buy today. Now, the software that we will be using on Windows computers only is BlHeli Suite, which I will also put in the description. This is made by BlHeli themselves and has all the software, all the firmware that you need to actually configure the ESCs to flash the firmware onto the ESCs and whatnot. It's also important to mention that not every single ESC supports BlHeli. For example, these ESCs, the common generic red bricks that you can buy off Amazon and eBay, do not support BlHeli. They have a Simon K bootloader built in, but they are just not set up hardware-wise to handle the demands of BlHeli. Although there are a lot of ESCs out there that can actually support BlHeli. I think most of them support BlHeli, and I will again link in the description all the ESCs that BlHeli recommends you can use with the software and what software versions are usable with those ESCs, because you have multiple revisions, multiple different software iterations per ESC, because not every single ESC runs on the same software, or rather not every single ESC runs on the same hardware. Therefore, they need different software to actually make use of the hardware that's been built into them. So you would wire this up the same way you would wire your quadcopter for flight. In the case of clean flight and better flight, this is motor 1, 2, 3, 4 or ESC 1, 2, 3, 4, and you would hook that up to the outputs on your Naze32 PWM out 1, 2, 3, 4 onwards. And then you can go into BlHeli Suite, and I'm going to show you that in a bit, how you can set up the interface so that you can flash BlHeli onto these ESCs. Okay, so after you've plugged in all of your ESCs to your flight controller, you can go ahead and connect your flight controller to your computer. Once that's done, it's important you select the right COM port. In my case, it's COM4. In your case, it might be something else, depending on the computer you have, depending on what ports you have open at the time. After that's done, for these particular ESCs, the Afro 12 amps, you go into select atmel/SI Labs make interface, and then you go and click number 6. We are using the BlHeli/Simon K bootloader clean flight for the Atmel chip. Because different ESCs have different chips built in, it's either going to be SI Labs or Atmel. In this case, the Afro ESCs are built in with Atmel, so we are going to select Atmel and the clean flight bootloader. We're going to click that, and even though it says clean flight, don't worry, you can use this with beta flight as well. I don't know why it says clean flight, but even if you have beta flight flashed, you can go ahead and do this. Rest assured it'll work just fine. It's also important to give your ESC's mains power from your battery, because the ESCs need that power in order to activate the circuitry that's required to take in information, to give out information, and to in general just be flashed. So I'm just going to give it power right now. I'm going to make sure I selected the right interface, and I'm going to connect. Once that's done, the important thing you do is to read setup. Now, some ESCs are going to come pre-built with BlHeli, so you're not going to have much of a problem. But some ESCs, you're going to have them pre-built, or rather pre-programmed with Simon K. Now, when you click read setup for these ESCs, what happens is you're going to get an error saying the ESC has either been erased or has been flashed with Simon K. And you just go ahead, you click OK. You don't need to think too much about it, don't worry about it, because even if it has Simon K built in, the point is you're going to overwrite that Simon K file with BlHeli. So right now that's what I'm going to do. I'm just going to click using the right click, you can actually select individual ESCs to look at the individual specs, and using the left click, you can select multiple ESCs. So I'm just going to look at ESC 1. I have BlHeli revision 14.9 on it. This one, ESC 2, has 14.0, which is an older firmware. So I'm going to be flashing everything together, and it should take care of this one as well. This one has BlHeli 14.9. This is BlHeli 14.9 as well. So I'm just going to select all of them, which is what I would recommend you do. Click Flash BlHeli. Select latest available BlHeli revision. Select multi, because this is a multi-copter, and select the corresponding ESC. So there are a lot of ESCs over here. Make sure that you are using the right file. For me, in my case, it's the Afro 12 amp. But please make sure, according to the document that has been linked in the description, whether it's SI Labs or the Atmel chip, make sure you're using the right firmware to be flashed into it. Be careful which software you select to be flashed into your ESCs. So I'm going to click OK. I've selected the right version. Click yes, and it's going to flash this onto all of the ESCs. It might do this, it might say not responding. Do not freak out, it's fine. It does that a lot. It does that all the time for me, and I freaked out at first, but don't worry, you'll get right through it. You don't need to think about it. And after that's done, you will be able to go and select a few of the settings that you can use for just generally good performance. So like I said, nothing went wrong. It was just program slowed down for a second. And click OK. Yes, I want to write the current settings to the ESC. Now this popped up for ESC number 2. Click OK. You'll have to do this 4 times so that it'll go through ESC 1, it'll go through ESC 2, and then ESC 3. Just go ahead and flash all 4 of them individually, and yeah, you'll be done in a few minutes, maybe a minute or 2. Now I do recommend that you remove your props before doing this, because you are giving live power to the ESCs, and I have seen the ESCs start up while being flashed, so please be careful. Please don't take any risks. Just take the propellers off just to be safe. You can have your motors connected to the ESCs. You don't absolutely need them to be connected to the ESCs, but if they are connected, please make sure that the propellers are disconnected, because you just don't want them spinning up and hurting you or hurting your hardware. Yes. And this is the last ESC. I'm gonna go ahead and flash it. This is unnecessary because it already has BlHeli 14.9 flashed onto it, but I'm just doing it just to show you how the process would happen. Alright, here are a few basic settings that you can make use of to make your ESCs run better. So first of all, I'm not going to go through every single setting that's on here. If you want to know what every single option here does, you can check out Joshua Bradwell's video that I've linked in the video description, and you can just check it out. He's going to go through every single thing that's on this BlHeli suite so you can know exactly what all of these options do. But just in general, I would recommend going and clicking on PWM frequency / damped right here and going into damp light. So traditionally, how an ESC would slow down a motor is it would just simply send it less power, so that the drag of the propeller is what slows the motor down. But in the case of damp light, what happens is the ESC actively brakes the motor. So if it's going at say 2000 RPM and it needs to get it down to 1500 RPM, instead of sending it less power so it gradually slows down to 1000 RPM, or rather 1500 RPM, the ESC will bring the speed down very quickly to 1500 RPM. And say the quadcopter is landing and you are going to shut off the power. The second you shut off the power for most ESCs running out of damp light mode, what will happen is the motors will keep spinning for a few seconds and then eventually stop due to friction. But in this case, as soon as you cut the power, the motors will just stop. So traditionally, what you would have to do if you wanted to make a motor spin the other direction, say it's spinning clockwise and you needed to make it spin counterclockwise, what you would have to do is take off heat shrink and then solder wires differently. But in BlHeli Suite, all you have to do is go into motor direction, select the motor that you want. For this example, I'm selecting motor number 2, and you go ahead and you go and click reverse. So now the motor, say it's spinning clockwise, it's going to reverse and spin counterclockwise. And now once you set up everything that you need, just click right setup, ESC right OK, click OK, and then you're done. What you can do after that is that you can actually go into the motors tab and just calibrate the motors, make sure the motors are spinning in the right direction. I'm not going to do that right now because you all know how calibration works. And you can just do your testing right here without having to disconnect, to open up Clean Flight or Beta Flight and then test it that way. Now, why on earth would you need to do all this? Basically, there are three main advantages to using BlHeli over Simon K. The first one is you are able to reverse the direction that your motors spin through software itself without having to desolder and then solder connections back together. Reason number two is you get better motor timing because of active braking. The flight controller will be able to control the speed of each motor more perfectly. Reason number three is you get faster throttle response through the use of One-Shot 125. Now, BlHeli comes pre-built with One-Shot 125, with more advanced versions of BlHeli such as BlHeli S supporting One-Shot 42, Multi-Shot, D-Shot, and so on. Now, not every single ESC can support anything other than One-Shot 125. For example, these ESCs, these Afro ESCs, simply don't have the hardware to support BlHeli S, although there are other ESCs out there that support BlHeli S that also support these advanced throttle timings. Now, most people aren't even going to get the full potential of One-Shot 125 because their flight controllers just don't have the processing power necessary to update its gyro quickly enough to send information to the ESCs. But for the most part, this is the best you can get for something like a Naze32. If you like this video, please hit the like button, please subscribe, comment, all of that good stuff. Share this video around with friends. We wish to build a community and we wish to teach people everything that we know. Click here to click here to subscribe to this channel, and click here to subscribe to my channel. My name is Chum, and if you wish to see more of my antics, you can find me over here. Thank you so much for watching.